All right, so this is going to be a quick video on input validation, and for the labs that you're doing for me, nothing after the second lab will have any user input at all. Zero keyboard input. Everything will either be hard-coded or come from a file, or generated randomly or something like that. So you're never actually going to use this, but since lab 2 did have that valid routine you had to write, I thought it was important to talk about, because while all of you did it correctly for the lab, that's not the way you'll do it for real in a real program, and you don't know the C++ yet to do it for real, so I wanted to show you that. So, you had something like this. I'm not going to write the whole thing, but I'm going to write this in Emacs, and the previous video you saw had Emacs in it, and you might have something like, I'm going to use double instead of int, and we'll say, and we're just going to output it, just whatever, and I'm just going to run a shell here in Emacs. And I'm going to look at the file, make sure I'm in the right directory, and run it from within here. I'll make the font a little bigger. And notice that it works. And of course, your program, you had an if statement, not an if statement, you had a while loop around this and an if statement to basically say as long as it, and it was an integer between, it had to be between 0 and 99 or something like that. The problem is, cin does a lot of work for you. Cin does a lot of conversions. It does parsing. And if you type in something like this, let's say I run this and I type in hello 23.4 world, my program keeps running, and it gives me a 0 for D, which is not correct. I mean, maybe I wanted the 23.4, but I certainly didn't want the hello. The problem is, nothing stops you from typing in strings and trying to convert it, into a number, and that's a real problem. It would be in some languages, if you did this, your program would crash, and I would argue, that having your program crash would actually be better than this, because here, if I might have thought, and maybe this was file input and there was some corrupted data in the file, and so hello went in instead of the 23.4. But the point is that I think it's 0 now, because 0 is a valid number and a valid double, and my program is just running merrily along and everything could be off. So it's actually probably better if this crashes than if it allows me to do this. But we don't know how to handle that yet. So the first thing to do to handle this is you always want to work with input should always be strings. And so instead of doing a cin to D, we can do std getLine into S, and we'll just print out what we get for S. And now it prints that out, and of course we type in, whoops. But the problem is this is not correct for our problem, because it's giving us, the whole string. But the point is it's not going to crash on us, and it's not going to give us the bad output, because once we have the string, we can look at its length. We can do all sorts of things for it. And in fact, what we can do is we can say standard stolv d equals of the string. We can do a standard, this is string to, I think, long double, or something, could look it up. But that'll do the conversion. So now if I run this and I type in 34, it prints out our 34. If I run it and do 23.44, it prints that out. And here, though, if I run it and I type in hello 23 world, well, that shouldn't have happened. Well, actually, is that okay? That should be crashing on me. Let me get rid of some cruft here. Let's compile this. Okay, and now I probably just didn't compile it. I probably was hitting the wrong up arrow key. So if I run this and I type in 23.4, it works. But if I type in hello, it crashes. And if I type in hello 23, it crashes. I think I was just not compiling it before. I was probably hitting the up arrow and just not paying attention. But this is actually good. And it's good because our program isn't going to run on some value that we don't expect. But the nice thing is C++ lets us handle this. And the way we can handle this is with a new construct called a try-catch. And the way try-catch works is whatever you put up top here in the try, it's going to try to do. And we're going to even put in here standard cout, the try worked. And here we'll say it crashed. And then we'll print out the E1. So it'll try to do whatever is up here, and if it works, it just works. So here, if we compile this, and let's make sure I actually compile it, it works and everything works perfectly. On the other hand, if I run a.out, I type in hello, it said it crashed and it got a standard exception. So that's how try-catch works. What try-catch does is it tries to do whatever is up top here, and if it works, it just goes to the bottom. But if it doesn't work, it does the catch part, and then it keeps running. So that's where you fix your problem. It's kind of like an if-then for errors. Now we can put this into a construct that will let us do valid correctly. At least I'll do it for double input. I won't do it for any range checking. So what we'll say here is while try again, we're going to keep trying stuff. What are we going to do? Well, the first thing we're going to do is we're going to get the line. And then if we get the line, when we get the line, we're going to try to convert it to D. Now, if this doesn't work, it's going to immediately jump to the catch block if it doesn't work. But if it does work, we can say try again equals false, because we don't have to try again. And then it's going to come down here, and we will have you entered, and then that value. On the other hand, in the crash, in this part, the catch, what we're going to do is we're going to say instead, try again, enter a number, and we'll say try again equals true, just to make sure that we're setting it to true. And that'll be that. And just to make this a little bit nicer, we'll say up here, standard cout, enter a number. So let's trace through this and then we'll run it. Basically, we're going to say, enter a number, try again is true, so it's going to go into here. We're going to then get our number, or get our input, but it's going to go into a string. We're going to try to convert it. If the conversion works, it goes to the next line, try again becomes false, goes to the bottom of the loop, try again is false, it exits, we're done. But on the other hand, if we enter a string and this crashes, if it gives us an exception, it jumps to here and it tells us to try again. So let's compile this. And that works. That works. But if we type in a string, it just stays within that loop. And when we enter something valid, it works. So that's the basics of how exceptions work. You'll learn more about them in 335. Again, this is not going to come up in our assignments for our class, but it's important for you to think about how to deal with real input, and the idea that you should always get your input in a way that's not going to crash your program, and then examine it to make sure it's the right type, it's in the right range, etc., etc. Okay, so that's it for this video. Just about a little under 12 minutes. And so that's that, and I'll see you all in class.